Next is in example 7, we have to use the remainder theorem to identify the zeros of the polynomial. So you see what does 0 means. To recap, 0 of the polynomial for f of x, 0 means solution of this equation. So if c is 0 of f of x, then f of c would be 0, right? So what is f of c? F of c is the remainder when you divide by x minus c. So we can use all these related facts. Let's see the a part. F of x is given to be 2x cube minus 4x square minus 13x minus 9, and c is given to be 4. The question is to check if c is the 0 of this. That means to check if f of c is equal to 0, which means to check if remainder is equal to 0 when we divide f of x by x minus c. Okay, so let's try that. How do we divide this? We write the coefficients of f of x. This is in the standard format, no term is missing. So I'm going to write coefficients of the functions, all the coefficients in the right order. I'm going to write c on this side here. So what do we have? We bring 2 down, multiply 2 by 4, which is 8, add these numbers, which will give us 4. 4 times 4 is 16, add these numbers, we have 3. 3 times 4 is 12, adding we get 3. So this is remainder, which will be f of 4, which is equal to 3 and which is non-zero. That means c is equal to 4 is not a 0 of the given function. Okay, let's try part B. We have x cube plus x square minus 3x minus 3. The question is to check if c is equal to root 3 is a 0 of the function or not. Part B, the function is given to be x cube plus x square minus 3x minus 3. The question is to check if c is equal to root 3 is a 0 of this or not. So we will divide f of x by x minus root 3. How do we do that? Using synthetic division. We write the coefficient of f of x 1, 1, negative 3, 3. They are in the correct standard format in the decreasing order of x, so we can just write the coefficients. We write c here, which is root 3. 1 comes down, 1 times root 3 is root 3. Adding them, we get 1 plus root 3. Root 3 multiplied with this would be root 3 plus 3. When we add them, we get root 3. This was negative here. Root 3 times root 3 is 3. When we add, we get 0. What did we get? That remainder is 0, which is also is equal to f of root 3, which is coming to be 0. So root 3 is a 0 of f of x. Next, we have to check if f of x is x cube plus x plus 10 and c is 1 plus 2 iota. This is iota. Iota is a special number. Let me explain. Before we start, here, iota is a complex number. It is square root of negative 1. So I know with that we said that square root of negative number is not defined. So then we define complex numbers. In complex number, it is defined, it is named as iota. Whenever there is square root of negative, we call that iota. So you see iota square would be square root of negative 1 times square root of negative 1, which will be negative 1. So iota square is basically -1. Similarly, if you were find iota cube, that would be square root of -1, square root of -1, square root of -1. That would be negative iota. Similarly, iota power 4 would be multiplying square root of -1 4 times. That would be 1. So these are some important facts for you to know. Complex numbers is a big chapter. We are not going into much details, but that's what you need to know right now. So let's look at part C. The function is given to be x raised to power 3 plus x plus 10, and C is given to be 1 plus 2 iota. It's a complex root. You want to check that if 1 plus 2 iota is a 0 of the function or not. So we're going to use the same synthetic division method. We're going to divide the function by x minus c. C is 1 plus 2 iota using synthetic division. How do we do that? We write the coefficients of f of x in the standard form x cube. X square term is missing, so we will write it like this, plus x plus 10. So we have the coefficients as 1, 0, 1, 10. And we write c here, 1 plus 2 iota. Everything else goes similarly. 1 goes down. 1 times this whole number will be 1 plus 2 iota. Adding these, we will get 1 plus 2 iota. 1 plus 2 iota times 1 plus 2 iota. So I'm going to show you here on the side. How can we multiply 1 plus 2 iota times 1 plus 2 iota? Distributive property, 1 plus 2 iota, then this multiplies with 2 iota plus 4 iota square. 1 plus 4 iota minus 4, because iota square is -1. So that is 4 iota minus 3. So we have -3 plus 4 iota. When we add, we get -2 plus 4 iota. Now we need to multiply 1 plus 2 iota with -2 plus 4 iota. Again, we use the distributive property. So 1 is being multiplied by -2, 1 is being multiplied by 4 iota, 2 iota is being multiplied with -2, and 2 iota being multiplied by 4 iota. What do we have? -2. This will cancel. This is -8, which is -10. So we will write -10 here. When we add, we write 0. This is 0, meaning remainder, which should be equal to f of c. C is 1 plus 2 iota is equal to 0. That means 1 plus 2 iota is a 0 of the given polynomial function. Next we have factor theorem. If f of x be a polynomial, if f of c is equal to 0, what does that mean? That would mean that c is a 0 of f of x, right? That clearly means that x minus c is a factor of f of x. Similarly, if x minus c is a factor of f of x, then f of c is 0, vice versa, right? So that is the factor theorem. If x minus c is a factor of the function, then f of c is equal to 0 clearly, and if f of c is equal to 0, then x minus c is a factor of the function. Let's see how we can use that in this example. Use the factor theorem to determine if the given polynomials are factors of this polynomial function. F of x is given to be x power 4 minus x cube minus 11x square plus 11x plus 12. We have to check if x minus 3 is a factor. So basically, I will divide f of x by x minus 3 and check if remainder is 0. That is what we have to check. So let's divide. For dividing, I'm going to use synthetic division. You write the coefficients of f of x: 1, -1, -11, 11 and 12. X minus 3, that means c is equal to 3. So I'm going to write 3 here. 1 goes down. 1 times 3. 3 plus -1 is 2. 3 times 2 is 6. -5. -15. -4. 3 times -4 is -12. And we have 0. What is that? That is the remainder is 0. So we can say x minus 3 is a factor of f of x. Check part B here. Part B, we have to check if x plus 2 is a factor. That means we're going to divide f of x by x plus 2, which can be written as x minus minus 2. So c is -2. We are going to use a synthetic division again. Write the coefficients of f of x, which are 1, -1, -11, 11 and 12. Write c here, which is -2, and do the synthetic division to check if the remainder is 0. 1 comes down. 1 times -2 is -2. Adding the column, we get -3. -2 times -3 is 6. Adding the column, we have -5. -2 times -5 is 10. Adding the columns, we have 21. -2 times 21 is -42. Adding the columns, we have -30, which is not equal to 0. That means because the remainder is not equal to 0, we can say x plus 2 is not a factor of the given function.